Question. Prove this inequality by induction. I answer this question. So here is for all n is larger than 1. So I start from 2. So for n equals 2, left hand side equals square root 1, 1 plus 1 over square root of 2. And this equals 1 plus 1 over square root of 2. And this equals 1 plus the top multiply square root of 2. Bottom also multiply square root of 2. And this equals 1 plus square root of 2 over 2. This is left hand side. Then the right hand side equals square root of 2. Now we need to prove that left hand side is larger than right hand side. So I can use left hand side to minus right hand side. And this equals 1 plus square root of 2 over 2 minus square root of 2. And this equals, we can change 1 to 2 over 2 plus square root of 2 over 2 minus here 2 multiply square root of 2 and bottom is 2. So this one is just this one. Then this equals 2. 2 plus square root of 2 minus 2 multiply square root of 2. And this equals 2 minus square root of 2 over 2. We know that 2 is larger than square root of 2. So this one is larger than 0. Then we know that left hand side is larger than right hand side. So the inequality holds for n equals 2. Now assume that it holds for n equals k. Here k is larger than 1. So we have 1 over square root of 1 plus 1 over square root of 2 plus until plus 1 over square root of k is larger than square root of k. Then for n equals k plus 1, left hand side equals 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of k plus 1 over square root of k plus 1. This is left hand side, and right hand side is just square root of k plus 1. Then to prove that left hand side is larger than right hand side, we can use left hand side minus right hand side. This equals left hand side 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of k plus 1 over square root of k plus 1. This is left hand side minus right hand side square root of k plus 1. If we can prove this one is larger than 0, then left hand side minus right hand side is larger than 0. Then left hand side is larger than right hand side. This is larger than square root of k plus 1 over square root of k plus 1 minus square root of k plus 1. Why the left side is larger than the right side is because this part is larger than this part. Because we assume this guy is larger than this guy. Then go ahead. Let's check this guy. Plus 1 over square root of k plus 1 minus square root of k plus 1. This one equals the first term. We can change it to square root of k multiply square root of k plus 1. And the bottom also multiply square root of k plus 1 plus 1 over square root of k plus 1 minus, so the top square root of k plus 1 multiply square root of k plus 1 bottom square root of k plus 1. Now this equals bottom square root of k plus 1 and the top square root of k multiply k plus 1. Then plus 1. Then minus k plus 1. And this equals square root of k plus 1. Square root of k multiply k plus 1 minus k. And this one is larger than square root of k squared minus k bottom square root of k plus 1. The left hand side is larger than the right hand side. It's because this guy is bigger than this guy. Then this guy, the right hand side equals here square root of k squared minus k equals 0. So this one equals 0. So this guy is larger than 0. The left hand side minus right hand side is larger than 0. The left hand side is larger than right hand side. The inequality holds for n equals k plus 1. Conclusion. The inequality holds for n equals 2. And if it holds for n equals k is larger than 1, then it also holds for n equals k plus 1. Therefore, 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of n is larger than square root of n for all n larger than 1 by the principle of mathematical induction.